Okay, let's quickly take a look at how the character pointer works in memory. You have an address, which is the address of the pointer that you've created with a statement something like this. Then you have the value for that statement, which when you declare it like this could be any random value. Most compilers do assign it a value of 0, which is a null pointer, but you can't rely on that. And then you have uh, when you assign new memory, allocate memory from the operating system, you get a block of memory of a certain size, which you have to specify, something like this, um, which will then give you a memory which is not initialized. It's just a bunch of memory that the operating system has given to you to store values. So if you have a character pointer like this, it will point to the first position in that block of memory. Then, as you use C strings, you will step through that memory incrementally, and until you get to the null character, which will then indicate that that's the end of the string. There may be more memory allocated to the C string, but that indicates that that's the end. Okay, so let's take a look at some code. As you can see here, we have some heap allocated memory, character pointer or string of length 6, and then we allocate 5 characters and obviously then the null character, and we print it out and we free the memory. Then we also have a stack allocated character array, which we also have length 6, and we print it out, and then we don't have to delete it because the compiler will take care of that for us. Okay, so let's see, do we get any memory leaks? And it's completely memory leak free. That's great. So let's try to now copy the stack allocated memory to the heap allocated memory with something like this. And now we'll see that it works. Forgot that. Okay, sorry. It works. Now, why is this? This is because we are pointing with that first character pointer that we created. We're pointing to the stack. This works, but it's very dangerous because the compiler will deallocate that memory which that pointer is pointing to whenever the greeting2 variable goes out of scope. So you might be pointing to a piece of memory which seems valid, but it's gone out of scope and been deallocated. But the memory values are still there, so it does seem fine. This means that it's you'll carry on, and then at some stage the operating system might reallocate that memory to another to something else, which will then make your pointer point to memory which is maybe not a valid C string or something like that, which could cause big problems and very hard to debug. So that's very bad to do that. So keep your stack and heap allocated memory separate. So if we want to do something like that safely, we would copy the string like this, and we should then not deallocate the memory, because we will copy that string to that memory, and then yeah. So let's see how that works. Okay, so it works. So let's see if we have any memory leaks. And yes, we do. We have a memory leak. That's because we did not deallocate that memory at the end. So doing something like this should solve that problem. And it's completely memory leak free. Okay, so now we understand when we should delete memory, when it's heap allocated, when it's stack allocated, and the dangers of combining or copying from heap and stack allocated memory. Yeah. Thanks for watching. Remember to vote and ask questions on the Google Moderator page, and hope to see you next week.